Continuous delivery is difficult to achieve. There are lots of things to get right to make it work. If you're starting out on a new project with nothing in place, it's relatively straightforward. But what if you're not? What if you already have lots of software and a new organisation in place and want to move towards continuous delivery? What are the 3.5 most common technical stumbling blocks that get in the way on the road to continuous delivery? It's easy to imagine starting out with continuous delivery when you have a blank sheet of paper, but that's rarely the case. Most of us don't start from that position. This video is in response to the commonest questions that I get about how to start with continuous delivery, and those are usually from people and organisations that already have a large body of software and an organisation and a culture in place. In fact, the same sorts of questions tend to come up over and over again. So I've collated a bunch of them into what I see as the 3.5 commonest technical barriers to achieving continuous delivery in those sorts of organisations. So let's explore those ideas and discuss how we can overcome those barriers. A good place to start is to think, what are we aiming for with continuous delivery? My favourite way of describing it is that continuous delivery is working so that a software is always in a releasable state. We're aiming to produce releasable software multiple times per day. You can't just turn that on. That takes an awful lot of things in place to make that happen. To become great at this, world class, takes a long time and involves a lot of learning along the way. So what are the difficulties that most teams face at the start? Here's my list of things. I think the biggest barrier in the technical sense is legacy code. We exist with a body of code that was written and predates large-scale automated testing, automated deployment, configuration management, and all of those sorts of things. Most organisations living in that world, as part of their release process, execute a detailed, thorough manual testing and release process, which is slow, inefficient, and, to be fair, error-prone. Most organisations also have something of a configuration management debt. They are not able to reliably and repeatably reproduce a deployed environment for their software, and so the software itself is a little bit unstable and a bit variable depending on where it's deployed and how it's being used. And finally, most organisations living in that kind of world tend to optimise to make sure that everybody's working really hard and is maximising the output and are very, very feature driven in terms of scheduling. So I'd like to talk about all of these ideas in a little bit more detail and start thinking about ways in which we can apply continuous delivery thinking to address them. First up, legacy code. My favourite definition of legacy code is from one of my friends, Michael Feathers, who described legacy code as code without tests. That's quite a nice starting point. If code that was designed without the assumption of automated testing is not the same shape as code that was designed from the ground up with automated testing and testability at its heart. And so introducing the idea of testability and automated testing into the release process and the body of code itself is a complicated task. I think the commonest problems associated with legacy code are these. There are no tests, no automated tests to speak of. There is often poor modularity in those systems. We tend to have started using the term monolith as a disparaging term, and really it's pointing to those sorts of systems that are complicated, deeply coupled, and hard to change is what we really mean when we say monolith these days. The build and deployment processes for such systems are often very slow. I've seen systems that require hours to build and sometimes even hours to deploy into production. And that's a problem if we're looking to achieve releasable outcomes multiple times per day. Data migration if we've got a system that users are using and benefiting from, they're probably generating a lot of information that we need to keep. We'd like to be able to modify the structure and the content of that information over time as we learn more things and evolve our software. And so taking data migration seriously is also part of the problem. And then many of these systems are built with old technology, sometimes so old that we may have even lost the compiler for that language and those sorts of situations. So let's talk about each of those problems in a bit more detail. This isn't all of the problems associated with legacy code, but they're the most common ones in my experience. So what's your experience? What other problems have you found that have got in the way when working in these kinds of environments? Please add comments below and let me know what sorts of problems you see and the solutions that you've identified to fix them. So let's start off with testability. Legacy code, as I said, part of the definition is probably doesn't have automated tests. So we want to start thinking about how we can make the code more testable. It's very difficult to retrofit automated testing to a pre-existing code base. So what does it take? And I think it takes two things. One is the strategy that we employ to start adding those tests. And second is what the strategies that we employ to make the code testable. So I want to address both of those. There's only really one route to making changes in legacy code that doesn't have any tests where we want to start adding tests. And that route doesn't involve trying to retrofit test fine-grained, test-driven development style unit tests across the board. That's disruptive and inappropriate in this scenario. Instead, what we're looking to do is that we're looking to try and defend the code in the areas where we're trying to change it. Let's imagine that we have a bundle of legacy code like this, and we are required at some point to introduce some change into that code. Then what we would really like is that we'd like to be able to make those changes safely and with the protection of some automated tests. We can't go in and refit detailed unit tests because that's going to be disruptive to the structure of the code and more risky than just making changes without the tests in some ways. So instead what we can use is that we can use higher level functional tests. We can write a series of tests from outside the system that kind of bracket the area in which we're trying to evaluate and provide some level of protection of those use cases. If we use the techniques of BDD and acceptance test driven development, you can apply that kind of black box whole system functional testing to almost any system, as long as you can simulate some inputs and collect some outputs to make an evaluation of whether the test was successful. That's all you need. It doesn't matter. And the nature of the technology, the nature of the system, you can nearly always do that. So we're going to build these tests from outside the system. We're going to evaluate the system just in the area that we want to change with those tests. And then we're going to start using techniques refactoring techniques to beef up the isolation of the piece of code where we'd like to do work. And then ultimately we can isolate that sufficiently by making the interfaces to those pieces of code more abstract and more decoupled, to the extent that we can then pull that piece of code out and then we can go to town on it. We can throw it away, we can change it, we can write the detailed TDD style low-level unit test that really allows us to evaluate the technical quality of those changes. This is the most effective technique for making change. It's hard work, it's difficult, there's an awful lot that goes into this, but this is the way into starting to change your legacy systems to make them more workable. It's going to probably never end up with a beautiful system. Some people refer to what I've just described as the strangler pattern, because you kind of strangle the system, pulling it apart bit by bit until there's kind of a rough structure of the old system, but with these little bubbles of better tested code. The strangler pattern is named after an Australian vine, a strangler vine that grows around the outside of trees and kills the tree and leaves kind of the shape of the tree but empty in the middle because the tree's dead. And that's kind of a fair mental model for what the outcome of this strategy leads to ultimately. The other part of this is the idea of making our code more testable. And the key skill that's involved here is associated with testing, but is not about testing. It's about refactoring. I think that refactoring in its strictest terms is a much undervalued process and an essential skill for any software developer, but specifically for software developers working in legacy code bases who need to migrate the code to be more workable. Refactoring allows us to make behavior preserving changes in the system that we're working on. That's what refactoring means. And so we can make tiny little steps to change the behavior of our system, to organize the code, to make it more tractable to testing in future, and also more understandable, more readable, and more effective, higher quality as a result of those changes. I'm going to give you 7 pieces of advice for refactoring in legacy code. I'm going to run through them quite quickly. If you're interested in covering these in more detail in some future episode, let me know in the comments below. First, we want to aim to remove clutter from the code. We start here. We're going to go through and we're going to try and remove unnecessary comments. We can use rename to rename variables to eliminate comments very often. We're going to delete dead code that's commented out or anything like that. We just want to try and get so we can have a clearer picture. We can make these changes in very small steps and we can commit after each step, and it's very, very hard to make those changes and break things if you just take those tiny steps and use good refactoring tools. The next step is we're going to work to try and reduce the cyclomatic complexity. If you're not familiar with the idea of cyclomatic complexity, it's really about the branchiness of a method or a piece of code. We're going to reduce that. We're going to simplify things, and we can start doing that by refactorings like extract method. You can kind of highlight a block of code within an if statement and give it a name. Say what that thing is doing, and that's going to clarify a piece of code. We're going to compose methods. We're going to start building methods that tell the story of what it is that they're trying to do. Again, using renaming techniques and extract method refactorings that allow us to pull blocks of code out and give them a name, a label that is descriptive and explains what's going on. That's kind of a fractal approach, and we can apply that broadly across the code and go deeper and deeper and deeper. We're going to remove duplication, and what happens is as you start with those first 3 steps, you're going to observe more and more duplication in the code, and that's going to prompt you to start thinking about pulling things out into different modules or classes or services and methods and so on, and you just keep going through that. We're going to aim to separate concerns and reduce the dependency in one place. If you've got a large method, it's probably doing many things. Pull each of those things out into a separate block of code, and it makes the code more tractable and more testable and nicer to work with. And finally, we're going to work in tiny steps. Each of these steps is going to be small and safe and easy to make. If you haven't read it, I very strongly recommend Martin Fowler's wonderful books. There are 2. He has 2 wonderful books on refactoring in code bases. They should be the tools of our trade. The last of my 7 is get yourselves a good integrated development environment, an IDE, and learn how to use it well. A modern IDE has great refactoring tools built in. The best ones that I'm familiar with are the ones from JetBrains family of products. Look into those. ReSharper in the .NET world and the IntelliJ family of development environments all have wonderful refactoring tools built into them and can make this job much safer and much more efficient. We want to improve the modularity of our systems. We want to be able to start to think about decomposing our large legacy block of code into pieces that we can change more safely with less anxiety. My advice here is to be strongly guided by the problem domain. You're looking to establish seams in the code that where you can increase the abstraction between the pieces. Again, this is hard work. This is difficult, but you do this step by step using the techniques of refactoring to guide you. So that's a key skill in this. And I also advise you to adopt the Boy Scout rule. If you're not familiar with the Boy Scout rule, the idea is every single time you go into the code base, leave the code in a better state than you found it. every single time. Just look for the tiny tidy ups, even if it's just 10 seconds to just rename something to make it clearer, or to pull out a method, or to reduce the cyclomatic complexity. Just make those tiny changes and make that a habit of your daily working. The other piece of advice that I would have is to make progress tactically. Try not to do this as some mammoth, massive project, because you're probably doomed to failure if you do that. Instead, try to find this tactically and allow it to be a little organic as you kind of discover and find the seams. Use the ideas of bounded context from domain-driven design to try and figure out which pieces of the code have a common view of the world. Those are the pieces that you want to try and look to tease out and start to draw lines between. The third in my list is speed. We want to be able to speed up slow builds and slow deploys. If we are looking to create a releasable outcome multiple times per day, we've got to take the speed and the efficiency of our feedback cycles very seriously. There's less general advice here. My primary advice here is to take the speed of the deployment and build seriously. We often tend to neglect those two areas in a code base and don't spend sufficient time making them efficient and well ordered and well written pieces of code. Look at your pieces of code and for deploy and build and analyze them and look to speed them up. I once worked with a client whose build process recompiled the code 7 times because they had circular dependencies in the code. That's just kind of crazy. It was only on the 7th iteration of the build where all of the code would compile because of the circular dependencies in their build. So go in and try and identify the circular dependencies or whatever else your problem is and weed them out. Treat this as an important thing. Experiment, try things out, try parallelizing things. Whatever's available. Think about using more modern technologies like Docker, even for legacy systems. If you can use that technologies, that might give you a leg up. Think about whatever it takes to get that feedback cycle down, and just experiment to find out what really works. Data migration requires deep automation. I'm going to skip over this to some extent, but my advice is put the responsibilities for the migration in the right place, in the right team, so that the people that are changing the structure of the data are responsible for writing the migrations. I intend to cover data migration in much more depth because it deserves much greater coverage than I have time to go into in this episode. To wrap up on the solutions for legacy code and to move on to manual testing and configuration management, the last of on my list of legacy code problems is the problem of old technology. And my advice is, it's not a problem. You can carry out continuous delivery with almost any technology. I have come across an organization that does full-on continuous delivery to mainframe computers for COBOL applications. They found that the acceptance testing in particular was easy for them because they could write their acceptance tests from the perspective of an external user of the system, testing through green screen dumb terminals. So old technology is not the barrier that we think it is. We just need to apply the thinking. If you need to write a new unit test framework or deployment system from scratch, those are not terribly difficult things to do. So old tech isn't really the problem unless you genuinely have lost the compiler, and then that might be a bit tougher. Second in my list of 3.5 things, manual test and release. This is the commonest pattern for releasing software in these sorts of organizations. My advice is automate all manual regression testing. There is no place for human regression testing. Adopt acceptance test driven development for all new work is a good starting point. And look to retroactively automate the testing that you feel is essential in order to release your software into production. Be driven by what you already do, automate that, and just that act will then save you an awful lot of time and effort and capacity to do more testing on top of that in future. So it keeps you doing what you are already doing, only better and more reliably if you can automate those tests. I'm going to do some more stuff on acceptance test driven development in future on the channel. In the meantime, if you want to look at one of my conference talks, Acceptance Testing for Continuous Delivery, it's got some good advice. Third in my list of 3.5 things, poor configuration management. Often these sorts of environments are manually configured. These are kind of snowflakes, works of art worked on by human beings at release time. We want to eliminate that. We can use the automated testing that we just talked about in the previous bit to drive the configuration management. If we want to automate manual testing, that's going to drive of necessity the automation of deployment. If we are automating deployment, that's going to drive the need for good configuration management. From the time when I started doing this kind of stuff, the tools have come on leaps and bounds. There are some excellent tools out there to help us with good configuration management. Take them seriously and start applying them to your legacy systems. They are wonderful tools that can help you a great deal. Use the ability to version control to drive tactical automation. Think that what you would like to be able to do is that every change to your production system of whatever kind, you'd like to be able to version control. That's going to help you steer towards the best practices in terms of automating these kinds of things. Work on the worst problems first. A good friend of mine, Keith Morris, in his wonderful book Infrastructure as Code, drew this lovely picture of the automation fear spiral. So we start off with, I make configuration changes outside of my automation tools. My servers are inconsistent. I'm afraid that running my automation tools will break something because my servers are inconsistent. And then I make changes outside of my automation tools, and so on and so on and so on. So we need to break that spiral. So we need to stop making changes manually. We need to start automating all of those steps. I'm going to talk more on infrastructure in code in future too, because that's also a topic that requires an awful lot more detailed coverage. So we've discussed 3 of my 3.5 things. Legacy testing, configuration management. What about the half? This is half because it's half technical and it's half organizational. This is a big deal. Nearly all of the organizations that I consult for try to organize their work by making sure that everybody's busy all of the time. And that's rather foolish. That's not the way to optimize delivery. Lean practitioners, I talk an awful lot about eliminating waste from a process. One of the forms of waste that they identify and even give a name to is overburden. If you are doing too much work, you will be going slower across the board at everything than if you reduce the amount of work that you focus on. Part of my history is in writing high performance systems, and for those sorts of systems we often focus on queuing theory. So just a little thought experiment. How do you optimize the throughput of a queue? If you want to maximize the throughput of a queue, do you put nothing in it? Of course not, that's stupid. Do you fully load the queue? Well, no, that's stupid too, because if you fully load the queue, you make it much more complicated to put things into the queue, and you make it much more demand on the things that are taking off the queue, and so on. It turns out if you apply thinking like Little's law and Amdahl's law and those sorts of things to most normal sorts of problems with a reasonable amount of parallelism in them, a queue, if you want to maximize the queue, the numbers come out at somewhere between 60 and 70% of the load of the queue if you want to maximize the throughput of that queue. Now, a software development team is full of clever people and all that kind of stuff, but in information terms, it's kind of a queue. We kind of stuff requirements in one end and we hope to get great software out the other end. So if you want to maximize the throughput of your software delivery team, you need to load that team at somewhere to 60 or 70% of its capacity. If you do more than that, it means that they can never cope with unexpected eventualities. It means that they are not free to help other teams to, if I walk across the room and say, oh, can you help me with this feature? I need this feature in your service. They're going to say, no, write a ticket and we'll be back to you in 6 months. If they've got a bit more capacity, they might be able to do that. It's going to unblock me, and organisationally that's a benefit to everybody. The outcome of this kind of thinking, when we apply it to software development teams in general, along with all of the other practices of continuous delivery, is that continuous delivery teams spend on average 44% more time on new work than teams that don't practice these sorts of disciplines. So that's a huge outcome on every front, from a technical perspective and from an organisational perspective. Arranging your development teams to just deliver feature is a bit like deciding to save money by not bothering to put oil into your car when the oil warning light comes out. You can probably carry on driving for a short time, but you're going to come grinding to a halt at some point in the future. So from the technical point of view, what can we do to kind of work on that if we're working as a software developer on a team? The first thing is take professional pride in the work that we do. When somebody asks you to do something, don't parse the question and say, well, we could do it in this long if we don't do any tests, and we can do it in this long if we do tests, because they're going to say don't do the tests. Running the tests and writing automated tests is part of your professional duty of care to do a good job. Adopt the Boy Scout rule. Take time and pride in your work. Go home feeling good about the things that you've done. Tidy up the code base. Make it a little bit better every time. Delete dead code. And the last thing, that my piece of advice in this category, is buy the book Accelerate for your managers. It would be worth the investment. In summary then, it's harder to do these sorts of things, continuous delivery, in pre-existing teams and organisations. But nearly everybody that practices continuous delivery started from there. Almost nobody gets the opportunity to do this from scratch with a blank sheet of paper. I've done it twice ever in my career. It takes work, sometimes very hard work, but it's worth it because the outcomes are so much better than the alternatives. Thank you very much for watching. Thank you too if you've already subscribed. If you haven't already subscribed and you'd like to see more videos, please do subscribe and hit the notification icon, and that way YouTube will keep you informed of new episodes. I also have 2 additional pieces of news. We're working on some video versions of my successful continuous delivery training courses, which will be available later in the summer. We're also introducing a mail list so that you can kind of keep up to date with what's going on the channel and with ideas on continuous delivery. If you're interested in either of those things, the details for signing up are below in the description. Thank you very much.